Hello, welcome to the video series on algebra. In the last several videos, we have learned how to define a set either by listing its members, or by using set builder notation to state the properties that every element of the set must satisfy. We also described several types of relations that can exist between sets. In this video, we will explore set operations such as intersections and unions, as well as visualizing these operations by using the Venn diagram. Let's get on to our lesson. A Venn diagram is a diagram that shows all the possible logical relations between a finite collection of different sets. In a Venn diagram, sets are usually represented by circles or other types of enclosed areas. The interior of the circle represents all the elements of the set. The exterior represents any elements that are not members of the set. For instance, let's say that we have two sets A and B drawn so that they don't overlap, which implies that the two sets contain entirely different elements. In this case, we say that the two sets are disjoint. Disjoint sets have no elements in common. If the two circles overlap, this indicates that there are one or more elements common to both sets. The intersecting area represents elements that are members of both A and B. This collection of common elements is called the intersection of sets A and B. We denote the intersection by a symbol which looks like an inverted U. This collection of common elements is a new set. For example, if set A contains the element 1, 2 and 3 and set B contains 2, 3 and 4. The elements which A and B have in common are 2 and 3. This intersection forms a new set containing the elements 2 and 3. Two disjoint sets have no elements in common, so their intersection forms the empty set. Using set builder notation, we can write the definition of an intersection of two sets formally as follows. The intersection of sets A and B is the set of all elements X such that X is a member of A, and X is a member of B. Another essential set operation is the union of sets. The union of two sets A and B includes all elements of either A or B. If set A and B have any elements in common, they are only included once in the union of the two sets. For instance, if set A contains the elements red, green, and blue, and set B contains green, blue, and white, then the elements which all members of A or B are red, green, blue, and white. The union of set A and B contain all of these elements. Notice that green and blue are common in both sets and are only included once in the union of the two sets. Using set builder notation, we can write the definition of the union of two sets formally as follows. The union of sets A and B is the set of all elements X such that X is a member of A or X is a member of B. Subsets and supersets can also be represented using Venn diagrams. In a Venn diagram, the subset is typically shown as a smaller region within the larger superset. For instance, in this diagram, set A is a subset of B, and set B is a superset of A. If we use a Venn diagram to illustrate the relations between the sets of numbers we have studied in pre-algebra. The diagram shows that the set of natural numbers is a subset of the set of whole numbers, which is a subset of the set of rational numbers. The union of the set of rational numbers and the set of irrational numbers is the set of real numbers. So far, we have seen how various relations between sets as well as set operations such as intersections and unions can be represented using Venn diagrams. In the next video, we will see how we can use the Venn diagram to visualize more complex set operations. Thank you for watching. If you liked the video, please don't forget to like and subscribe. Please post any comments or questions to the comment section below.